Z is a present value random variable for a 30-year term life insurance on age X, payable at the moment of death. We're given the force of interest of 4%, and we want to find the probability that Z is greater than 0.25. So Z, well, the benefit here is not stated, but it's going to be 1. Raise that to negative 0.04 times t to the x. And that is when tx is less than or equal to 30. Okay, so because this is a 30-year term, it'll only pay out if the person dies within the 30 years. And it's going to get 0 otherwise. So, all right. So now we want to see when is e to negative 0.04 times tx greater than 0.25. Okay, so we're going to take the log of both sides, divide by negative 0.04, and get tx is less than ln of 0.25 over negative 0.04. So this is 34.66. So we transform this problem into probability of survival. So we're really looking for the probability that tx is less than 34.66. Notice this is a 30-year term, so nothing happens after 30 years. There's no payout. So this is equivalent to saying the probability of dying within 30 years. And this is age X. So it doesn't matter what age this is issued. It was issued age X, but because the force of mortality is constant, it doesn't matter. Okay, so let's look at a graph just so we're clear what's happening. So let's say this is my present value. So this is Z, this is time till death. We're looking for the probability that Z is less than 0.25, but we found that it's always less than 0.25. So it's actually, for values 34.66 and to the left, it's always less than 0.25. So we converted this into, well, instead of looking at the present value random variable, we said that's the same thing as a person surviving or dying within the 34.66 years. But notice here there's nothing going on. So that's the same thing as somebody dying within 30 years. Because that's where everything happens. So that we can write it as 30qx. So for the first 10 years, the force of mortality, let's see, is 0.01. And then afterwards, it's 0.04 or 0.02. So let's do 1 minus. Now think of it as surviving. Well, we have 1% for 10 years, and then 2% another 20 years. So we find the complement, which is really 1 minus e to negative 0.5. And the final answer is 0.3935.